In this lecture, we will look at the bar chart. Now, bar charts are very simple. We create it on Excel all the time. And they can also be very interesting because they can reveal very subtle details about plots. Let's look at a new data set called diamonds. This is again an inbuilt data set available inside R, and we have the prices of over 50,000 diamonds. We have the price, the carat, the cut, the color, the clarity, the XYZ value, which is the length, width, and the depth, like this. Let's create a simple plot. So ggplot, and the data is equal to diamonds, and the geometric bar mapping is equal to aesthetic, and we want to simply look at the cut. Let us run this and we get a simple bar chart like this. So on the x-axis we have the cut, which is a variable from the diamonds: fair, good, very good, premium, and ideal. And on the y-axis we have the count. But think about it, the count is not a variable in the diamonds. So where is it coming from? Now, many graphs like the scatter plot plot the raw values of our dataset, and other graphs like the bar chart also have the ability of calculating new values to the plot. So I hope this makes sense. All right. Let's look at something different now. We have something called stat, which is nothing but a statistical transformation. So if I write the same code like this, and rather than writing the geometric bar, we write stat count, you notice that the result will be exactly the same. And this works because every geom has a default stat and every stat has a default geom. This means that we can typically use geoms without worrying about the underlying statistical transformations. Let's take an example. I'm going to take a variable called demo in which I want to save a tribble, and the tribble is containing some values. So we want to put the cut, and then we want to keep the frequency, and we want to write here fair is coming, let's say 1610, and then good is coming 4906. We have very good 12082. We have premium 13791, and finally we have ideal at 21551. ggplot, in fact I can just copy this. No, let me write it. So ggplot, the data is equal to demo, and the geometric bar mapping is equal to the aesthetic mapping, where x is equal to the cut, y is equal to the frequency, and the stat is equal to the identity. Let's run this and the result. Let me just try once again. Run and run. And are we still not getting the result? Just give me a moment. Let me see if there is something that I've not done correctly. So we have the demo triple and everything seems okay. Let me check. The geom bar mapping, aesthetic mapping, x is equal to cut. Okay, I put an extra 0 here. Silly mistake. Let me run this and it still refuses to work. Okay, no problem. Let's quickly see if there's anything else that is not put correctly. So we have the triple, we have the cut, we have the frequency. We have taken the data demo. We have taken the mapping as the aesthetic mapping, x is equal to the cut, y is equal to the frequency, and I forgot to close the parentheses. Really sorry about that, silly mistakes. One last time, run, and you notice we get a result. Now do not worry if you have not seen this symbol or the triple earlier, but I hope you can guess the meaning. What we are doing is, to create a data set called a triple, which is like this, containing the cut and the frequency, and we are saving that in a name called demo. And that is the name that we are using here. But we will be covering these things a little later. Okay, we might also want to display the bar chart as proportion rather than the count. Let's see how we do this. So what I want to do here is, x is the cut, the y is the stat prop, which is nothing but the proportion, and then we also say group is equal to 1. And what this means is that the result will come like this. And let me also do this with the diamonds data so that you can see and understand this properly. So with the diamonds data, you can see that we are looking at the proportion now like this. So do you see these are percentages on the y-axis? It's a very simple and easy way of not looking at the count but looking at the proportion. Now, if you want to draw greater attention to the statistical transformation, we can also use stat summary. Stat summary. Once again, we use the diamonds data and we will put a stat summary. Our mapping is equal to the aesthetic mapping. X is equal to the cut. Y is equal to the depth. Then we have the max is equal to the max, and then finally we have equal to the median. I hope all of you can understand what this is. We are basically trying to create a statistical plot, which means when I write fun.max, all we are doing is we are looking at the max function, right, and the min function. Let's see how the result looks. Let me run it. And the result looks like this. So what we are looking at is for each and every one of the x-axis values, which is the cut, fair, good, very good, premium and ideal, we're able to see the results like this. The min, max and the median, which is the dot plotted here. Now ggplot has over 20 different stats that we can use, and each stat is a function, which means that we can get the help in the usual way. So I can simply write question mark stat underscore bin, and as you can see, it tells me a lot about the different types available inside. Now, I don't expect you to read all of it, but definitely remember that whenever you get stuck, this is a very nice way of finding a little bit of explanation about what you're doing. So we have done bar charts, but let's also look at position arguments. And this is a little bit of magic that we want to add. So we will take our diamonds data set and we will keep the mapping as cut, and we will keep only one more thing, which is the color as the cut. Right? Let's see the result. We get this. Let me do it one more time. This time we will keep the fill as the cut. And you notice we get different colors now. Make sense? Now, what do you think will happen if I keep another variable inside the fill? Like right now we have the cut inside, but what if I keep something else? Let's see. For example, if we put the clarity, we will get the result as a stacked column chart like this. So we have 5 columns each for the cut, and in each column we have different stacks, which is showing us all the different clarities available. And the stacking is performed automatically by the position adjustment specified by the position argument. So if you don't want a stacked bar chart, you can use identity, dodge, or fill, something we will cover later. In fact, let's look at a little bit of this. Let's look at one example. I want to take the same thing once again, and this time we want to keep the data as diamonds. We have the mapping as x is equal to cut, and then the fill is equal to clarity. That looks good. Then we want to keep a geom bar where our alpha is equal to 1 by 5 and the position is equal to the identity. Remember, we used this earlier as well when I was showing you the example with the dribble. Let's see how this works now. When I run this, you get a result like this, and I hope all of you can see the transparency. Obviously, it goes without saying, if you keep the alpha as 2 by 5, it comes like this, and if you keep it as 4 by 5, it becomes even more prominent. And if you only keep NA, this means that you simply want to show, just a moment, no, we don't want to keep the alpha as NA, we want to keep the fill as a NA. This means that the fill color will not be shown at all, and it should only show you the borders. Just give me a moment. Just a second. So we want to keep the color as our clarity, and the position is identity, the fill is NA. I think this seems okay. Let's see. Perfect. Now this time you notice we only get a very interesting sort of a bar chart like this. But what if we don't want a stacked bar chart? What if we want a 100% bar chart? To do that, let's just copy these 2 lines. We will keep the fill as clarity, and then we will keep the position as our fill. And let's see the result. This time we don't get a regular stacked, we get a 100% stacked bar chart. We can also use the dodge, very simple. So if I just copy this and change the fill with the dodge, you can see the result. It comes like this, where each of the different clarities are represented as a different line and not as a stacked single line. Excellent. Now, even though we have used dodge for the bar chart, remember they can be used with scatter plots as well. So if you recall, we had created our scatter plot earlier. The very first one, which was this one. And this looks great. We have the highway and the displacement. But the problem is that what if one of these dots actually has 3-4 more hiding behind it, and which we can't even see properly? That is where something can help us. We can write the data as MPG, and the X is the displacement, the Y is the highway, and we want to keep the position as what we call jitter. And see the result. Let me do it once again. Okay, there should be a geom.point. Very nice, isn't it? Just by creating a jitter, you notice that we can avoid the gridding, which means that we don't have multiple points coming one on top of the other. So we get a little bit of random noise around each point. And because we are spreading the point, no two points will have the same amount of random noise. Now I know this might seem like a very strange way to improve the plot, but this can be a helpful tool to have as and when you require it. Let's also look at the coordinate systems. Now these are some of the most complicated part of ggplot, and we don't want to get into details, but you should know that we are using the Cartesian coordinate system, which means that the X and the Y position act independently to determine the location of the point. Let's take an example. We will keep ggplot, and let's take the MPG data, mapping AES, the class, and the highway. Box plot. Let's copy the same thing once again. All this is okay, but this time I want to add what is called the flip, like this. Let me show both of them to you. The first one looks like this. We get a box plot where we can see the interquartile range, we can see the outliers, the mean and the median. And in the second one, we are basically flipping it. That means I'm reversing the X and the Y axis. And this can be very, very helpful. Let's take one more example, a slightly more detailed one, a more advanced example, but you should be able to follow it by now. I'm saving NZ, and what is it that I'm saving? Map data, and we have NZ. All right. Now we want to create ggplot with New Zealand and aesthetic, where my long and my lat and my group is equal to group. You don't need to focus a lot on this example. We are basically creating a plot, a map plot, as you might have guessed. So we want to keep the fill as, let's say, I don't know, white, and we can keep the color as black. Let's see the result, everyone. So we get the result like this. So we get a map of the region New Zealand. Now we have the country, but we want to make it look a little better, right? Because it's spatial data. So the aspect ratio has to be correct. And to do that is very simple. We can simply write underscore quick map. And as you can see, it automatically fixes the spatial data. That means the ratio becomes proper. We can also create some more advanced charts like this. Let's take an example. So I'll say that in bar, let's save ggplot and let's put our diamonds data. Our mapping is equal to aesthetic mapping, x is equal to the cut, the fill is equal to the cut, and show legend is set to false, and the width is equal to 1. Let's also add something more. So the theme aspect ratio is 1, and in labs we can keep the x as null and the y as null. Let's see the result that we get, everyone. So when I run this, let me just complete it, bar plus code underscore flip. Okay. So you notice we get a nice bar chart like this with 5 results in it. Look what will happen the moment I write bar plus polar. You'll get a very interesting visual which looks like this. It's a very easy to understand plot and it just looks very different, and I think the key here is it's different. It's not that it's better, but in case the client wants to see something a little different than the usual charts, I think this is a great chart to be able to use. Excellent. So we have done quite a lot of things, everyone, and in the next lecture we will come back to the basics. So far we have had some experience of running our code, but we want to focus on all the small things within R. So we will do it one by one, and I will see you for the next lecture.